Differential equations 2000, question 10b. So this question here is type 2 real world, which is linear motion. We're told the deceleration of a particle moving in a straight line with speed v meters per second has a magnitude of 4e to the power of v over 6 meters per second squared, and it has an initial speed of 6 meters per second. So we want to find the time, t1, for the speed to decrease to 3 meters per second. So we're looking at change in speed and we're looking for time. So therefore, because we're giving our equation for acceleration, we're going to use dv dt. So we have velocity and time for our limits, so it has to be dv dt. So our acceleration is decreasing, so therefore it has to be minus 4e to the power of v over 6, and that's going to equal to dv dt. And if I rearrange that equation to separate out my dv's and my v's and my t's, I'm going to divide across by the e to the power of v over 6. So that'll be 1 over e to the v6. Let's make that a bit bigger. So 1 over e to the power of v over 6 dv. And multiply across by dt gives me minus 4 dt. And therefore, if I go to integrate both sides, I know I can't integrate 1 over e, so I'm going to write that as e to the power of minus v over 6 dv. And now it's okay to integrate. So I need to add in my limits. So what are my start limits? Well, at the start, I know that the initial speed is 6 meters per second. So we're going to say v is equal to 6 meters per second. And the initial time would be 0. And then at the end, we're looking for the time. So we're going to be calling that t1. And it's decreasing its speed to 3 meters per second. So v is going to be 3 meters per second. And t we're calling t1. So our end limits are our upper limits. And our start limits are our lower limits. So if I integrate e to the power of minus v over 6 with respect to v, well, integrating an exponential is just e. But I must divide by the derivative of the power here. So if I differentiate minus v over 6, I just get minus a sixth. So I must divide by that derivative. My limits are 3 and 6. If I integrate minus 4 with respect to t, I get minus 4t. And my limits are t and 0. I'm just going to tidy this up first. I'm dividing by a fraction, so I'm going to turn that upside down and multiply. So it's going to be minus 6e to the power of minus v over 6. And now it's a bit easier to sub in our limits. So upper limit minus lower limit is going to be minus 6e to the power of minus 3 over 6. So minus 3 over 6 is minus a half. And then that's minus 6e to the power of minus 6 over 6, which is just minus 1. And then that's going to be minus 4t minus 0. Okay, so tidying that up, we end up with minus 6e to the power of minus a half. And then it's going to be minus 6. So that's going to be plus 6e to the power of minus 1. And that's equal to minus 4t. So we want to try and get t on its own. So I'm going to multiply across by minus 1 and then divide across by 4. So we end up with 4t is equal to 6 e to the power of minus a half plus 6e to the minus 1. So I can take out 6 as being common there and divide across by 4, which leaves me with e to the power of minus a half plus e to the power of minus 1. And that should be t1 I should be putting in there. If I go back, t1. And that should be t1, and t1. So therefore we can say t1 is equal to 3 over 2. E to the power of minus a half is 1 over the square root of e, and e to the power of minus 1 is 1 over e. Okay, so if we go back to the second part of the question, then it says find the time t2 for the particle to come to rest. So for the particle to come to rest means then that our end limits would actually be 0. So this would now be 0. So everything we've integrated there is going to be the same, just the limits are going to change. So if I go back, I will be saying in part 2 that T2 is going to be equal to, so after we've integrated, the only thing that's changing here is the upper limits, is 0 and T2. So if we now sub in our upper limits, we end up with minus 6e to the power of 0 minus 6e to the power of minus 1 is equal to minus 4t2, and anything to the power of 0 is equal to 1. So therefore that gives me minus 6 plus 6e to the power of minus 1 is equal to minus 4t2. So again, if I multiply everything across by minus 1, we get 4t2 is equal to 6 minus 6e to the minus 1. And again, if I take out 6 as being common, I'm left with 1 minus 1 over e. And dividing across by 4 gives me 3 over 2, 1 minus 1 over e. So now we have T2. So it then says, well, deduce that T2 minus T1 over T1 is equal to root e. So that means we're going to take T2 minus, so T2 minus T1 and put it over T1. And we want to end up with root e. So T2, we've said, is 3 over 2 times 1 minus 1 over e. And then minus T1. Well, T1 is 3 over 2, 1 over root e minus 1 over e. And that's all over T1. So that's 3 over 2, 1 over root e minus 1 over e. And we can see there that 3 over 2 is common. So I'm going to divide everything above and below by 3 over 2 and get rid of my brackets on the top line. So my 1 over e's are going to cancel. So we have minus 1 over e plus 1 over e is 0. So that leaves me with 1 minus 1 over root e on the top and 1 over root e minus 1 over e on the bottom. So I'm going to multiply the top and the bottom by the conjugate, which is 1 over root e plus 1 over e. So that gives me 1 minus 1 over root e times 1 over root e plus 1 over e. And on the bottom, 1 over root e minus 1 over e times 1 over root e plus 1 over e. So on the top line there we have 1 over root e plus 1 over e minus 1 over e minus 1 over e root e. On the bottom we have 1 over e plus 1 over e root e minus 1 over e root e minus 1 over e squared. So we have gone. So on the top line then, we're left with 1 over root e minus 1 over e root e. And on the bottom, 1 over e minus 1 over e squared. So if I get a common denominator on the top line there, we have e minus 1 over e root e. And on the bottom, we have e minus 1 over e squared. So turning it upside down and multiplying, we have e minus 1 over e root e times e squared over e minus 1. And of course, e minus 1 goes into e minus 1 once, and e goes into e once, which gives us e over root e, which is of course root e. So in terms of marks, we had 5 marks for setting up, and 5 for setting up our integrand, 5 for integrating, and 5 for getting T1, 5 for getting T2, and then there was 5 marks for finishing off and getting root e. So often that last bit is worth 5 marks. So if we get stuck in it, we sometimes don't have to be worrying too much about losing a lot of marks. Most of the time it's only 5. So a good test of your algebra there. And of course, you could have multiplied the top and the bottom there by e back up here rather than getting your conjugate. There's various ways in which we could have tidied up that end bit.